Hello guys, welcome back to my channel. So in today's video, we are going to dive into the concept of reflection agents. Before we get into it, let's clarify the flow of today's video. We will start by understanding three key things. What is reflection? When do you use it? And how can you implement it? For those of you who have been following along, I'm assuming you have already built a language model that interacts with external environments like search engine or a web scraper. If not, don't worry. Check out my previous videos where I guide you step by step on how to create one. Now let's address a challenge that many of you face. When building language agents, one of the hardest parts is enabling them to learn effectively from trial and error. So let me ask you this. What happens when your agent doesn't work as expected? Does it keep making the same mistakes again and again? Think about this. This is something which we all face when working with AI agents. It's frustrating, right? You have put in a lot of effort, but it doesn't just seem to work. But don't worry. That's exactly why reflection agent exists. And we are going to dive into how they solve the problem. A reflection agent is like a critique of its own actions. After performing a task, it pauses to reflect on what went right, what went wrong, how can it improve for future tasks. Think of it as teaching the agent to be self-aware. It's not just executing the commands, it's learning from its mistakes to become better over time. For example, if you have worked with AI agents, you will know that they can sometimes provide incomplete or incorrect responses. A reflection agent, on the other hand, can analyze the feedback it receives from the environment or the user, identify patterns in its errors, and adjust its strategies to improve its performance. So when should you really use reflection agents? Here are three scenarios where they really shine. First, when trial and error is really common. If your task involves exploration or iterative problem solving, a reflection agent can help you make the process smoother and smarter over time. Second, when performance matters. Let's say the agent success rate directly impacts its usability, maybe in something critical like a healthcare or e-commerce. In these cases, learning from mistakes is non-negotiable. And third, when the continuous improvement is needed. Think about scenarios where your agent needs to handle new challenges or edge cases that weren't part of initial training. These are just a few examples of when reflection agents can take your AI project to the next level. Now let's talk about some real world examples of how reflection based AI is being applied in different fields. In healthcare, it's being used to analyze patient feedback and refine diagnosis models. Imagine an AI improving its ability to detect health issues based on patient data over time. In e-commerce, reflection-based agents help improve personalized recommendations by learning from user behavior. Think of it as your shopping assistant getting smarter every time you browse. And in gaming, non-player characters or NPCs can now learn from players' interaction and adapt their strategies. It's like playing against an opponent that evolves just like a human. Pretty cool, right? These examples show how reflection-based AI is transforming industries by making systems smarter and more adaptable. Alright, so let's break this down into four simple steps to help you understand how to use reflection in your agents. Step 1, action. This is where the agent performs the task, like answering a query or scraping data. Step 2 is observation. Once the task is complete, the agent collects feedback or results from its environment. This could be feedback from a user or data about how well it performed. Step 3 is reflection. Here is where the magic happens. The agent evaluates what went well, what didn't go as planned, and why. It's essentially critiquing itself. And finally, the step 4 is adaptation. The agent updates its model, strategy, or behavior based on what it learned from the reflection process. This is how it improves over time and avoids making the same mistake. Simple, right? This cycle of action, observation, reflection, and adaptation is what makes reflection agents so powerful. Alright, now it's time to see this in action. In the next section of this video, we will walk you through some Python code to implement a reflection agent. So we will start with importing the environment variables. from .env import load.env. Let's call this function. Before moving ahead, I would like to give an idea about what exactly we are going to perform in this exercise. We will start with an article, and the generation node is going to use a AI model to generate a concise summary. And then the reflection node is going to evaluate the summary based on specific parameters to ensure its meaningfulness and effectiveness. Now let's see what all parameters we are going to use for evaluation of the summary. So when creating or evaluating a summary, there are four key metrics to keep in mind. First, the completeness. Does the summary cover all the key points from the original text or not? It shouldn't leave out any important details. The next one is relevance. Is the summary focused on the main ideas? It should highlight what truly matters without including unnecessary information. Then comes coherence. The summary should flow logically. Make it easy to read and understand. Each sentence should connect naturally to the next. And finally, conciseness. A good summary is short and to the point. It captures the essence without adding fluff. By following these four metrics, you can ensure your summaries are clear, effective, and impactful. We are going to capture these parameters in a Pydantic object. For that, we are going to import base model from Pydantic, and we are going to create a class of our own. Let's name it matrix. It is going to be derived from base model. This class is going to contain four parameters: completeness, relevance, coherence, and conciseness. Next, we have to define the states for our input, generation, and reflection node. Let's look at how exactly we are going to do that. So from typing, import, type dict, let's create our first class, which is input state. This class is only going to contain the article. The second class is a generation class, generation state. This is going to contain the article as well as the summary generated by the model. And the third class is going to be a reflection class. So reflection state, type dict. This class is going to contain the article, the summary, and it is going to contain an instance of matrix. Next, we are going to import an instance of chat OpenAI. So let's just import chat OpenAI from LangChain OpenAI. Let's create an instance of this. The model which we are going to use here is GPT-4. We need the reflection node to return the output in a structured format. And for that, we are going to use a method provided by LLM. That is LLM with a structured output. Here we can provide our own schema in which we want the output to be provided by the large language model. Next, we have to create two functions. First function is going to be the generation function. Another one is going to be a reflection function. Generation function is going to generate the summary given an article, and the reflection function is going to reflect on that summary based on the given parameters. Let's write our first function. The generation function is going to take the input and it is going to generate the generation state. This function is going to be called in two scenarios. The first scenario when the article is passed for the first time to the graph. And the second case is when the reflection node has provided a feedback on the summary which has been generated. Now let's look at the prompt of the two scenarios. In the first scenario, you can see that the prompt only takes the input article as an input. In the second scenario, you can see that we have the summary as well as the reflection matrix provided in the prompt. In both the cases, the output generated is going to be the generation state. It is going to contain the article and the summary. where in the first case it is going to be the initial summary, and in the second case it is going to be an improvised summary. Now let's write down our next function, which is reflection function. This again is going to take an input and it is going to return a reflection state. This time, notice that we are not using LLM, but we are using LLM with struct output because we want the large language model to return the matrix, which is containing our four parameters, that is completeness, relevance, coherence, and conciseness. Let's look at the prompt as well. It is a very simple prompt which is going to take in the summary as well as the article, and it is going to score it based on these four parameters. The next function which we are going to write is going to check whether the reflection node is able to meet a certain criteria or not. In this particular case, we can see that the completeness, relevance, and coherence is being set to greater than equal to 85, and conciseness is being set to greater than equal to 80. This is up to you what values you want to set. If this criteria is met, we don't have to go back to the generation node and we can return the final result. If not, the node is going to take the control back to the generation node and the generation is going to happen again. Now let's combine all these functions into a LangGraph. For that, first let's import state graph from LangGraph. Let's also import the start and the end node. And then let's define our graph. State graph. We'll just write reflection state inside this. We are also going to provide the input state as the input state. Let's add some nodes to it. The first node being the generation node, the second node being the reflection node. Now let's add an edge between the start node and the generation node. There will be an edge between the generation node and the reflection node. And then there is finally going to be a conditional edge from the reflection node. So this conditional edge is going to use the check condition which we just created, and that is going to decide whether to go back to the generation node or go to the end. Now let's compile this. Now let's look at the graph. This is how our graph looks like. Now to call this graph, we just need to use the invoke function, and the only thing which we need to provide as an input to this graph is the article. Let's take an article from Wikipedia and use it here. Let's store the output in out variable. So this is where we have got the summary which follows all the criterias in the first attempt itself. Now this is not very common, so let's try it out again. And as you can see, this time when the summary is getting generated, it took 2 attempts to generate the summary. Because in the first attempt, the completeness was just 60 and the coherence was just 70. But in the next attempt, when these parameters are being fed back to the generation is being done in such a way that it produces the matrix which are following the certain criteria. So that's it. That's how you can create a reflection agent. If you like the content, please do like and subscribe and follow for more updates.